Hello guys, today we're doing our 3.2 principal inverse trig values. Remember when I mentioned this in class, the first thing you have to know is the restricted range. The restricted range of cosine, secant, and cotangent are the same, almost the same. If you look at cosine, you look at secant and cotangent, you will notice that they go from 0 to pi. And that's exactly what to remember it, we use the cot and say cosine and his brother secant lie on the cot. In other words, for cosine and secant, the restricted range is from 0 all the way till pi. Of course, for secant and cotangent, I mean actually only for secant, we have a restriction there. It cannot be equal to pi over 2, because if it's equal to pi over 2, you get undefined. Compared to the other one, the other function that are not cosine, secant, or cotangent, in other words, for sine, for cosecant, and for tangent, they are on the side belly or big belly, meaning from here to here. In other words, it's from negative pi over 2 to pi over 2. Let's go ahead and practice this. Let's go ahead and find the exact principal value in radian, and of course this is a non-calculator side or portion. To find this, let's start with number 1. It says arc sine of square root of 3 over 2. You understand that arc sine is the inverse sine. The sine is made from the opposite over the hypotenuse. So apparently we're in a triangle where the opposite is square root of 3 and the hypotenuse is 2. Since it's positive, top and bottom are positive, you understand that it's in the first quadrant. And if it's in the first quadrant where the opposite is square root of 3 and the hypotenuse is 2, the angle that we're looking for here is actually a 60-degree angle. But because we're doing everything in radian, instead of 60, I would say it's pi over 3. And that is my answer. But we know that the reference, of course, is 60. Let's do the same thing for the next one. We have the sine inverse of negative 1/2. If we think about the restricted range, sine is in the big belly or belly side, the side belly. Being in the side belly, positive is in the first quadrant, negative is in the fourth quadrant. Negative, I know, is in the fourth quadrant, but sine again is opposite over hypotenuse. Hypotenuse is 2, opposite is 1. So it's in a 30, 60, 90, where the opposite is 1. Therefore, we're talking about the 30-degree reference angle. Reference angle is 30, but look what quadrant is located in. It should be in the fourth quadrant. Therefore, instead of 30, because the restricted range is negative pi over 2 to pi over 2, the angle will be negative pi over 6. Now, let's talk about cosine. Here's the cosine inverse, square root of 2 over 2. You should understand that it's just a fancy form of 1 over square root of 2. And the cosine is made from the adjacent over the hypotenuse. Which triangle has the hypotenuse of square root of 2 and the adjacent of 1? Of course, it's a 45, 45, 90 triangle. So the fact that it's all positive, I know it's in the first quadrant because the cot is all in the first or second quadrant. Positive first quadrant, negative second quadrant. Being in the first quadrant, I know that my angle is nothing other than pi over 4. Let's do the same thing for number 4. Number 4, I have a negative square root of 3 over 2. This time it's negative, so it's no longer in the first quadrant, but it's in the cot, meaning above here. And positive is the first quadrant, negative is over here. So I know my angle is somewhere here. But what is the reference angle? The reference angle in this specific problem, knowing that this is the adjacent and this is the hypotenuse, where the adjacent is square root of 3. Therefore, the angle itself is the reference angle. Let's start with the reference angle. Adjacent is negative square root of 3. That makes the opposite 1, and this is 2. Therefore, the angle or the reference angle is 30. Now, if the reference angle is 30, of course, we're going to do 180 because we want this portion of the angle. We will do 180 minus the reference angle. So that would be pi minus pi over 6, and my answer is 5 pi over 6. In other words, if it's in the second quadrant, you do pi minus the angle. Let's talk about tangent now. This is tangent of square root of 3 over 2. You should understand that this is also 1 over square root of 3, where now the opposite is 1 and the adjacent is square root of 3. Opposite 1, that's a 30-degree angle. Positive, first quadrant. Answer is pi over 6. For this one now, we have tangent inverse. It's this time negative. Negative is not in the cut, so it's what we usually say big belly. Since it's on the side belly, all we have to do is know that it's in the fourth quadrant, and this is over 1. In other words, the opposite is square root of 3 and the adjacent is 1. Opposite being square root of 3, we know that the angle is pi over 3, but in the fourth quadrant, we will say it's negative pi over 3. All right, let's do number 7. Number 7, we have sine inverse is 0. Whenever you have a sine, cosine, secant or cosecant that is 0, -1 or 1, you must be on the axis. That's, you can use your OI, or I owe you, or I don't owe you. It's up to you. But sine itself is what we call big belly, so it's located somewhere here. So what are the coordinates of this point? This point has coordinates of 1, 0. So the angle that we have 0 as a sine, remember it's cosine, sine. The angle that we have 0 as a sine is the angle 0. You cannot say 360 because 360 is not between pi over 2 or negative pi over 2 and pi over 2. So you got to stick in the restricted range. That wasn't a pretty color, by the way. Now, let's look at our cotangent. Cotangent this time is adjacent over the opposites. Remember, it's over 1. Cot, that's in the first or second quadrant. First quadrant if it's positive, second quadrant if it's negative. So it's in here. Remember, our formula is pi minus the reference angle. Which angle has an opposite of 1 and an adjacent of square root of 3? That will be a 30-degree angle. So I will do minus pi over 6. Pi minus pi over 6 is 5 pi over 6. Let's do the same thing for the cosecant. Remember, nothing on the bottom is over 1. Cosecant is hypotenuse over opposite. The hypotenuse is square root of 2. Because the hypotenuse is square root of 2, I know that it's a 45, 45, 90. Cosecant is in the big belly. Therefore, positive is in the first quadrant, negative is in the fourth quadrant. And if it's in the fourth quadrant, all I need to know is negative pi over 4 because that's a 45-degree angle. The secant is -2. -2 over 1, of course. So I will say my hypotenuse is 2 and my adjacent is 1. The only triangle that has a hypotenuse of 2 is a 30, 60, 90. Adjacent 1, that means it's a, by the way, before I go there, we know it's in the cut and it's negative, so it's in this quadrant. Now, adjacent being 1, I know that is a 60-degree angle. 60-degree angle is just a reference. So reference 60-degree. And we say we do pi minus 60 or pi minus pi over 3. That will give you 2 pi over 3. For tangent inverse, we have tangent inverse. Once I see -1, I kind of suspect to be on the axis. But what I mentioned is it will only be on the axis if you have sine, cosine, secant, and cosecant. For tangent, it's a whole different story. Because tangent is just telling you that the opposite over the adjacent is equal to 1. That must be a 45, 45, 90. But tangent is the big belly. So because it's the big belly, we know that positive will be in the first quadrant, negative will be in the fourth quadrant. Because I know it's negative, I know it's in the fourth quadrant. So what I would do is find a reference angle and stick a negative in front of it. So that would be negative pi over 4, because the only triangle that we have 1 and 1 would be a 45, 45, 90. Last problem, the R cosine. Cosine inverse, that means that's the adjacent here, and this is the hypotenuse. Unfortunately, it will make it harder to solve it this way. So let's go ahead and transform this fancy expression into something as -1 over square root of 2. Now I know that my adjacent is 1 and my hypotenuse is square root of 2. Square root of 2 as the hypotenuse is the 45, 45, 90. Negative, that means since it's in the cut, it's going to end up in the second quadrant. Now, reference angle is of course 45, so this is 45. fourth quadrant, I mean second quadrant, I need to say pi minus pi over 4, and that will be 3 pi over 4. Let's go ahead and summarize it. If the ratio of side is positive, the answer is the reference is positive first of all. And not only is going to be positive, but also it's going to be the reference angle. So I would say positive reference angle. Now, if the ratio of side is negative, we have two options. By the way, all positive reference angle, they will be in quadrant 1. If now the ratio of the side is negative, you got to think about cut or big bend. Cosine and his brother stick lie on the cut. That means negative will be in the quadrant 2. Compared to the other one, the negative is in quadrant 4. Now, if it's in quadrant 4, I don't expect you to do any special math. All you have to do is negative, negative, you can put negative of reference angle. Compared to when it's quadrant 2, you got to do pi minus the reference angle. Or, of course, if we're talking about degree, you will do 180 minus the same reference angle. All right, what if now you on the axis? What if you have cosine, secant, sine, or cosecant that is equal to this specific value, -1, 0, or 1? Now you're on the axis. You got to either use, when I say the axis, I mean the point that you're looking for might be one of these points. Unfortunately, you got to know the coordinates of each axis. And if you don't know the coordinates of each axis, you should remember OIO, or I owe you, or I don't owe you. So either you pick to know all the coordinates, or you pick to know OIO, I owe you, or I don't owe you. For example, this is 1, 0. If I ask you for the cosine inverse of 1, you should know that it's in a cut. The only one that has a cosine inverse of 1 will be 0 degrees, because the cosine is 1 here, and so on. Come prepared, and remember that I will give you one of these maybe as you walk in class, just to check your understanding.